Today, we're going to talk about can we ever travel the speed of light? So, if you still do not know what's the speed of light, it is the speed limit of the universe. So, let's say we have a rocket ship here that has a rest mass of 100,000 kilograms, and then it just fly away and travels the speed of light. So, the speed of light is basically the speed limit of the universe. It's going to be 3 times 10 raised to the 8 meters per second. It's going to be 300,000 kilometers per second. It's going to be 186,000 miles per second. So the answer here is basically no. Reasons? We need an infinite amount of energy to power a rocket at that speed. So if we're going to travel at the speed of light, we need an infinite amount of energy. But if we're going to... Okay, let's just calculate that kinetic energy that we need. So let's just use this classical physics law. We have 100,000 kilograms and we have speed of light that's going to be 3 times 10 raised to the 8 meters per second squared. So how much kinetic energy we need to power this rocket at that right speed? So that's going to be 4.5 times 10 raised to the 21 joules of energy. So that's how much kinetic energy that we need. So we need an infinite amount of energy to power rocket speed. That is around 4.5 times 10 raised to the 21 joules of energy. And we will take around 285,388 years to be generated by the strongest power plant we had. So that's a lot of years. That's around 200 centuries. That's 2 centuries. 300,000 years. So another reason is in special relativity, as we travel at the speed of light, the classical law that governs a matter just doesn't exist. So meaning, classical law will never apply. As an object travels close to the speed of light, it basically gains mass. So we have a statistics for that, and we also have a relativistic mass equation for that. So if we do travel to the speed of light, our rocket will just basically gain mass itself. Also, the time will slow down because as we travel the speed of light, our time will just slow down. So we also have this. So this is the stats here. We have mass and velocity. So in 50% of the speed of light, it's going to be 1.1, the increase in mass. And we will have an increase in mass, twice the increase in mass at 87%. And in 99%, that's going to be 7 times the original mass. So if we do travel at the speed of light, that will become infinity. And therefore, we cannot achieve that mass. Or we will basically be just turned into an energy once again because of Einstein energy equivalence equation. So as we approach the speed of light, the mass will approach infinity, and the energy we need will also approach infinity based on these two equations. So we have the relativistic mass, and we also have the energy equivalence by Einstein. So if we do travel the speed of light, we will be just maybe we just become form of energy and we just gain mass. So that's it.